Today we're going to take a look at a couple of problems. First one here, calcium hydroxide used to neutralize acid spills reacts with hydrochloric acid according to the following equation. All right, looks like I have 1 mole of calcium hydroxide reacts with 2 moles of HCl to form 1 mole of calcium chloride and 2 moles of water. Let's suppose that I spilled 6.3 moles of HCl and I put 2.8 moles of calcium hydroxide on it. Which substance is the limiting reactant? Okay, so in this case, I have 6.3 moles of that, and I have 2.8 moles of that. So those are my givens. I've given this here, and I want to know what the limiting reactant is. Okay, so that tells me I have a couple of ways that I can do this problem. Okay, and so I'm going to do it 2 ways for you. One is fairly straightforward. I'm going to pick a product and ask myself how many moles of that will I make, and I'm going to convert both of these into that and find out which one gives me the smaller value. So let's start with 2.8 moles of calcium hydroxide. I know my mole ratio here is 2 moles of water for 1 mole of calcium hydroxide. So since I have moles, I don't need a molar mass, so I'll just use this right as it is. 2 moles of water for every 1 mole of CaOH2. Right? So I grab my calculator, and I have 2.8 times 2 divided by 1 gets me 5.6 moles of water. Now, so I've got that one down. Now let's use the other one. I have 6.3 moles of HCl. It's got a 2 to 2 mole ratio from the balanced equation, so I'm going to use 2 moles of water over, in this case it's HCl, 2 moles of HCl. Plug that in my calculator, and voila, that cancels out. I get 6.3 moles of water. So what this tells me is that if all 2.8 moles of calcium hydroxide react according to this equation, it's going to make 5.6 moles of water. If all of my HCl reacts according to this equation, I'm going to get 6.3 moles of water. Well, since I'm reacting these with each other, the calcium hydroxide will run out after I've made 5.6 moles of water, even though I have enough HCl to make this much water. So this tells me, this lower value tells me that that's all I can make, and that the reactant that gave me that is my limiting reactant. So my limiting reactant is calcium hydroxide. The other way that I can do this problem is to just convert one of these directly into the other and compare with how much I have. So I'll show you what that looks like here. If I have 2.8 moles of calcium hydroxide and I have a 2 to 1 mole ratio, right? 2 moles of HCl for every 1 mole of CaOH2, that's going to get me 2.8 times 2 divided by 1. Oh, looks like the same answer here. 5.6 moles of HCl. Okay, so that tells me if I look at this, right, 6.3 moles of HCl is greater than 5.6 moles of HCl. Therefore, calcium hydroxide is the limiting reactant. Okay? Because I have more on hand than I'm going to use in the equation. Okay? We want to know how many moles of the excess reactant remain. Well, that's what this calculation over here allows me to do. I have on hand 6.3 moles of HCl. I'm going to use up 5.6 moles of HCl, and so when I subtract those, 6.3 minus 5.6, I get 0.7 moles of HCl left over. Another way I could do that is by taking a look at this. If I start with this, the amount that I know I'm going to use, right? Or know that I get from here, 5.6 moles of water. And this is really kind of a poor example because I have a one-to-one relationship here, but you get to see how the mole ratio is used. There's 2 moles of water for every 2 moles of HCl, which gets me 5.6 moles of HCl used, right? Which again is the same answer as I got up here. It should be that this answer and this answer are the same because I get the same answer here. That's how much I used up. Doesn't matter where I go to get it, but this is just another way to use it. It's to start with how much the limiting reactant gives me, calculate back to figure out how much of the other reactant I have, and you get the same amount from both ones, 5.6 moles, 5.6 moles, and so I have 0.7 moles of HCl left over. All right, let's take a look at one more. All right. In this case, I have zinc sulfide, and I'm going to heat it in the presence of oxygen to get this following reaction. So zinc sulfide will react with oxygen in a, looks like I need to balance this equation first, because notice I have 2 oxygens over here, but I have 3 on this side. So let's take care of that first. Right? I know that I'm going to end up needing 2 of these so that the 2 oxygens can come together there. So I'm going to have 2 of those. That's going to get me 2 of those zinc oxides, which will get me another one, but that's getting me 2 of those as well. So now with this one, I'm going to have 2 individual oxygen atoms there that will make an O2, and then 2 other O2s here, so this will be 3. So let me rewrite that next to this here so it's clearer. 2 ZNO plus 3 O2 molecules will form 2 ZNO plus 2 SO2 molecules, right? So now, I'm asking this equation, if I have 1.72 moles of zinc sulfide, right? Sorry, I wrote this wrong up here. Let's fix that. That's sulfide. 1.72 is heated in the presence of 3.04 moles of O2. Which one is the limiting reactant? Okay, here I had myself a note to balance the equation. It's a good thing we did that. Right? I'm going to do that by comparing this, convert this into that, and then compare them because I'm not asked about any of the products, so I can just compare one to the other. So if I have 1.72 moles of ZNS, and I know that I have a mole ratio of 3 oxygen for every 2 zinc sulfide, right? 3 moles of O2 for every 2 moles of ZNS. Then that tells me I'm going to need here 1.72 times 3 divided by 2, 2.58 moles of O2 reacts. Right? So I'm going to make a comparison. I have 3.04 moles of O2 on hand. That is greater than 2.58 moles. And so therefore, the zinc sulfide is the limiting reactant. It runs out first, so I can only make a little bit. So how much of the excess reactant remains? Well, I have 3.04 moles of O2. I'm going to use up 2.58 moles of O2. And so my answer here, 3.04 minus 2.58 is 0.46 moles of O2 left over. Right? So that's a little different than the ones that you've seen this last week. We'll do one more like that in this problem right here. Okay. In this case, we're going to look at the commercial production of arsenic. In this process, arsenic 3 oxide is heated with carbon, which reduces the oxide to the metal according to this following equation. So we're given the equation right there. Okay. I've got 8.87 grams of arsenic 3 oxide, so that's right there. And 5.33 grams of arsenic is produced, right? That's that one. What's the percent yield, right? Well, this one is not a limiting reactant problem because I only have one reactant. So I'm just going to start off with the amount of that reactant because I'm asked about this. What's the percent yield? I'm told I have a product that I make, so I want to find out how much of this I can theoretically make. So this is a theoretical yield calculation. Right, so I have 8.87 grams of As2O3. Right? And I'm going to try and find out how much arsenic I should be able to make from this. So I'm going to need the molar mass, 1 mole of As2O3. All right, I'm going to have to take a look at my periodic table here to find out what this is. Arsenic here is 74.92. I have 2 of those in there, plus I've got 16 times 3 for my oxygens, and so I have 197.84. Okay, so 197.84 grams of arsenic 2 oxide. Okay, so that will get me from arsenic 2 oxide to moles, so now I can use my mole ratio. In this case, there are 4 arsenic moles, right? 4 moles of arsenic for every 2 moles of arsenic 3 oxide. Okay. I need to convert that to grams so I can compare it here. So let's find out what the molar mass is. 1 mole of arsenic. We saw that here on our periodic table. It's 74.92. 74.92 grams of arsenic. All right, so let's plug that in our calculator. 8.87 divided by 197.84 times 4 divided by 2 times 74.92. All right, that gets me 6.72 grams of arsenic. That's my theoretical yield. Okay, so in this case, I want to know what the percent yield is. Well, I'm told that I actually get that much. So I have 5.33 grams that I collected divided by 6.72 grams theoretically. So my actual that I got divided by my theoretical times 100 will give me the percent. I can look at that here. 5.33 divided by 6.72 times 100, and I get 79.3% as my percent yield. Okay, This is similar. Right? In this case, I have 67 grams of oxygen in a different reaction, and this time I make 425 grams of arsenic. Calculate the percent yield. So this time I'm going to use carbon, and since it's still arsenic, I'm still going to convert that to the arsenic, and so let's see where this goes. 67 grams of carbon times 1 mole of carbon over 12.01 grams off my periodic table. My mole ratio is 4 moles of arsenic for every 3 moles of carbon. And I get this from up here. 1 mole of arsenic weighs 74.92 grams. Right? So plug this in my calculator here. 67 divided by 12.01 times 4 divided by 3 times 74.92 equals 557. So theoretically, I could make 557.27 grams of arsenic. But I'm told that I actually get this much, right? So my actual yield over my theoretical yield times 100 equals my percent yield. All right, so I just have to plug this in. All right, 425 grams over 557.27 grams times 100 gives me the answer. So 425 divided by 557.27 times 100 equals 76.26%. All right, so that's my percent yield for this problem. And that's all we have for this one. Hope that helps. Thanks for watching.